Welcome to PressGrid.com Network and Security Training Program. This is a job-oriented hands-on training program that will provide depth knowledge of network IPv4, IPv6 addressing, LAN, MAN, WAN, routing protocols such as OSPF, BGP, EIGRP, static routes, RIP, switching protocols, spanning tree, firewall security, load balancing, cloud networks, monitoring tools, and network troubleshooting, and network architecture with the 15 hands-on labs, daily short quizzes, quickly quiz, weekly quizzes, comprehensive test at the end of the course. Moreover, this training program will coach you how to crack your technical and behavioral interviews as well. And certification, yes, student must successfully complete the full training program, including the labs, daily quiz, weekly and comprehensive test to get the certificate. And for this course prerequisite, there is no prerequisite. That's a good thing. Anyone can learn this training program. Anyone. If you want to be network engineer, yes, you can be a network engineer. All you need is a good computer or laptop to study and complete this training program. And you must complete this training program in day wise in order. You must complete all the assignments and labs in order to become a good network engineer. Okay. And you need a good laptop to run some network simulator like a Cisco Packet Tracer or GNS3 to perform the labs. Now let's deep dive into the this network training index. So yes, this is a timeline. Like day one, we'll talk about introduction to networks, OSI models, TCP/IP, fundamentals of Cisco iOS devices or networking devices, fundamentals of IP addresses, subnetworker, IP, advanced IP addressing, introduction to routing protocols, static routes with the use case and labs, ARP, DNS, DHCP, advanced IP addressing, and then routing protocols such as RIP, IGRP, OSPF, and then we'll jump into introduction to switching. We'll leave the BGP at the end because BGP is very important protocol. So you must know OSPF, RIP, static routing protocols, and switching, and your IP addressing fundamentals before you jump into BGP. Because in most of the organizations, BGP is widely being used in the all corporate networks and internet networks, right? So we'll do BGP after a few days, right? So switching protocols, wide area network, HSRP, host and by routing protocol, VRRP, network security, advanced network security, netting, PAT, advanced routing, and then we'll jump into the BGP. Okay. BGP, Lab 1, Lab 2, MPLS, introduction to firewall, and then firewall lab, introduction to Wireshark lab, SolarWinds. SolarWinds is basically network monitoring tools. VPN IPsec site-to-site tunnel, introduction to load balancer, fundamentals of cloud networks, advanced cloud networking, fundamental of virtualization like a VMware, fundamentals of the Linux, how to configure IP address and the Linux Ethernet ports or Linux ports, right? We'll look into the what are the useful commands and network architecture like data center network architecture, corporate office network architecture. We'll deep dive into it. And then there will be lab, practice, practice, practice. Okay, and then comprehensive exam, and then we'll help you to for interview QA and prep, like what kind of interview questions interviewer can ask you for network engineer role or network architecture. Okay, so good thing is about in the network engineer, there are many roles. That's where you only need to work on routing protocols such as OSPF or BGP. And there are many roles that you need to work on switching. But it's very important to make sure that you know learn all the concept and your all concept are clear and you want to practice the labs, right? Whatever we do in these training programs, again at home, you must practice all the labs by yourself, right? Now today let's jump into the day one introduction to the network. So what is a computer network, right? This is the first question comes in our mind. Like the concept of the computer network might seems complex, but it's a fundamentally quite straightforward. Okay, a computer network is just a group of computers and devices linked together in a way that allow them to communicate and share resources with each other, right? So a computer network is a set of interconnected computers that communicate with each other to share resources and information. And now for an example, let's take an example of what is a computer network, right? This is left side you see here is a home computer network. So in this home computer network, you see CCTV, Wi-Fi is on, right? Audio, your broadband gateway is connected right here. Printer is there, media server, right? All your devices are connected to your home network wireless, right? So this is imagine your home setup with the multiple devices, right? And they are all connected, sharing a common link like this Wi-Fi to internet and even resources among the each other, right? And now, for an example, why it's important. Without imagine world without the networks, right? Now you have 4 or 5 members in your house, and each member is need to use a printer. They can, if somebody is sitting here in the first floor, they can just simply give a, print. They can print it, right? Even if you are sitting anywhere, you can just send a printer print, and you can print whatever documents you need. But now if there is no network, right, then what will happen? Each person will there require their own printer, or they need to walk to their printer, right, and again physically connect their devices and set up it from the scratch, right, and then configure it, and then they can print it. So it's a super mess, right? So with the network, it's easy for everyone, right? Everyone can just simply print whatever they want when they are in this home network. And now another example, let's say, like, if your friend is living in some other continent, like you are in the United States and your friend is living in Europe or Asia, right? And you want to send some files to your friends, probably the picture or whatever you want to share with your friend, right? And you need to send, copy all this file into USB drive, USB sticks, right? And then you copy them and then mail it to them. It takes weeks to deliver them, and then your friend can receive those files. But now with the network, it's very easy. You just open an email, like a Gmail account or any other email ID, right? And you can simply attach those files and send it to your friend, and your friends can receive it in a second. So this is the useful of the network. Why do we need the network? Right now you have a complete idea. And now if we talk about the network, right? So what is the biggest network? What is the comes in your mind, right? What can be the biggest network? So yes, internet, right? That's day to day you are using. Everybody is using the internet. Internet is the biggest network because internet is a global network of networks, right? And that connects millions of private, public, academic, business, and government networks, and it is the largest and most well-known of a wide area network. So remember, internet is a wide area network example. And all your remote offices, right? Your university campus is connected. Let's say if you are in Los Angeles, your university campus is connected to the internet. And if somebody is sitting in New York City, that's also connected, right? So many networks of networks that connects millions of like a private and public, businesses. And that's why it's become the largest network in the world. So if someone asks you what is the biggest network in the world, you should think about the internet. Oh, okay. Because internet connects everyone, and that's why it's become the largest network, right? Your home network is connected to internet. Your university network is connected to internet. Your Starbucks, or if you go into any coffee shop, right? That's network is connected to the internet. You go into stadiums for any right? That is also connected to the internet. So that's why it become network of networks. All right. Now, what are the types of network in your mind it comes in, right? Local area network. So local area network, if anything is less than 1 kilometer, then you use the local area network. So local area network is limited to small areas such as a single building, office, or your university campus, or your labs or library, and ideal for a small to medium size businesses. And it's limited to small geographic area. Okay, that says cons. and it requires significant cabling and infrastructure for larger setups. Next, metropolitan area network, right? So metropolitan area networks, that's range is 1 to 50 kilometers. In the metropolitan network area, uh, it's a smaller, it's bigger than LAN, but it's again, you will see smaller than a WAN area network. It main covers larger geographic area than local area network because local area network range is only 1 kilometer, right? You can send it within a right. You can send it within a 1 kilometer, but your metropolitan area network is 1 to 50 kilometers. So it's a large, obviously, it's a larger than local area network, and it's vast, spans across city or like a larger campus. And what is a wide area networks? Internet, right? Again, you can think about internet because anything is more than 50 kilometers, it's called wide area network, and it's a broad area often spanning across many cities, countries, or continents, and that's become like a internet, right? So internet is the biggest network of networks, right? Connects to the internet, and that's why it become the biggest network in the world. So internet is a global WAN that connects networks worldwide. And now, what is a wireless area, local area network? So it's provide all the benefits same as a local area network, but without the needs of the physical cables. You don't need any physical cables. If you go to the Starbucks or any coffees, right, you simply connect to the wireless network and you can access the internet. You don't need a physical cable to connect it, right? So it's a similar to the local area network, but without the cable. Okay, so that's a main advantage of wireless local area network. And there are some security concerns as well in the wireless local area network because anyone can interference your network traffic, right? So it's recommended that you should always use a VPN, especially if you're working for any corporate network. If you want to use any public networks or airport networks or any workstations like any in the train stations or any Starbucks or any public restaurants, that's time if you are using any first thing you shouldn't be using your public network to connect to your corporate network, right? But you can use a VPN if it's very urgent. And there is a performance issue as well, right? If there is any multiple walls or anything comes in, right, physical barrier, then your performance can slow down in the wireless local area network. Now, wireless, one other example here you see is also right stadium, Starbucks, coffees, or any restaurants. And internet we know is a global network and it's a network of networks. So network between organizations and it enables the communication, information sharing. You can send emails or you can access any website or streams any videos over the internet. So again, we continue the types of the networks intranet. What is the intranet? So internet is a private network, we can call that a private computer network within the organization to securely share information for internal communication. So intranet connection is shared between different parts of organization. For example, if Cisco, right? Cisco has an office. So Cisco office is a network is a private network. They don't want to share with any other third-party people or make it available to the internet, right, to any other. So if only Cisco employees can access to the internet network. So that's the internet, right? Because it's restricted to the single boundary and it's restricted within for their own employees. So it's like limited users are allowed to access this, right? If you're not Cisco employees, you cannot access the Cisco internet network. And now extranet is a little bit opposite to intranet, right? Any number of intranets combines to form extranets. Any number of intranets, right? Two organizations can combine their network to form an extranet. So company's intranet that is extended to user outside the company. So if the Cisco company ties up with any other Google network or any other, right, they will provide access to some third-party vendors or like a partners, suppliers to access their networks. But that network will be limited, right? And that's called the extranet. So now we call next is a virtual private network. So what is a virtual private network? So if Cisco employees uh, are, let's say, SFO, as Cisco campus is in SFO, and some of the Cisco employees travel to then New York City, right? And they want to access while they are sitting in the New York City, they want to access to the SFO Cisco campus network. How they will use? There is a virtual private network, right? It's a secure way of connecting to the private local area network that remote location. So currently their employee is sitting is in the New York City, but can simply use the VPN to connect to the Cisco San Francisco Cisco office, okay, or any other. Okay, if it's if cities in the New York City, but they want to access the um, Dallas network, Dallas, Dallas network office, they can simply remote VPN to it and access it. So all and also remote employees are connecting to their company's internal network securely over the internet. So it's a secure way of connecting it. What is a storage area network? So storage area network is a network of computing devices, storage devices. SAN is a specialized high-speed network that connects and provide access to storage device, such as the disk arrays or tap libraries or multiple servers. So multiple servers can access to the shared storage network area. Let's deep dive into the what are the computer network devices. So it's like a computer and server. So computers, including desktop, laptop, servers, and other devices, are fundamental components of the connected to the network, right? And repeater. A repeater basically nothing but extend the range of the network by amplifying and retransmitting the signals, helping overcome signal loss in a long distance communication. Still, some people use the repeater, but right now no one use the repeater. I can give you one example of the repeater. Let's say you have house and your house backyard and perimeter. This is your house, right? And your router is somewhere in the living room right here, and your router range is only within this network, right? So you can install one repeater here, uh, and it will extend the range of your house network till here. So if your garage is here, right, when you drive in here, you can still access your home network by using the repeater. If now we have a advanced router that has a like higher capacity and that can cover this area. But now you are using your home network, right? And you want to share it with your neighbors. So your neighbors are sitting here, they cannot access to your um, home network. And now you want to share it with your neighbors, right? And then you install one repeater here in between. And you will maybe install another one here, right? And that can give full coverage to them. So basically, you are getting internet connection from Verizon or AT&T or any other provider internet connections, right? And that you are sharing with your neighbors as well. How they are getting access to it by using the repeater, right? So repeater simply extends and they will amplify and extend the range of your home network. So your home network is within this perimeter, but it will be extended by using the repeater, and your neighbors can successfully access it, right? But usually it's not recommended to share with your neighbors or anyone because the privacy prospect, right, and security, because of security concern reasons. And hubs are a basic networking device that connects multiple devices in the network. However, unlike the switches, hub broadcast data to all network devices, right? So if hub is a simple, like it was a basic device, it was invented before the switches, right? So if there are many devices are connected, what Hub simply will do, Hub simply will broadcast all signal to all the devices, right? So performance become is slow and response is very low as well. And now we don't use the hub. And simpler to bridge, right? Bridge connects two or more network segments and operate at the data link layer. We'll deep dive into data link layer in the next session when we learn the OSI model. Okay. In OSI model, we'll deep dive into it. Right now, just get yourself familiar with these terms, right? We don't use hub, we don't use a bridge anymore. So just wanted to give you some idea about hubs and bridge, but don't worry about it. We don't need too much deep dive. You just need to know, yeah, there is a bridge device, right? It was, but now you won't find it anywhere because it's outdated devices. Divide larger network into segments and keep the traffic on each segment separate, controllers and isolate problem links as well. Bridges are smarter than hub. Okay, and now switch. Switch are smarter than bridge as well. So this we don't use. Okay. Switch connects multiple devices within a local network and use a MAC address. We'll look into the MAC address as well. What is a MAC address and IP address is, and provides bridging functionality with a greater efficiency. And each port has a buffer for each link, store and forward. And bridge, basically switch is a smarter devices than hub and bridge. So that's why we don't use any more hub and bridge. We are using the switch in the most of the data center and network. And we'll deep dive into it when we learn introduction to network. What are the different types of the switches? Like what switch, where do you want to use which switch? We'll deep dive into it during the when we learn about the switches. Okay, so don't worry, just get yourself familiar with the terms. What are the networking devices, right? So again, hub, bridge, we don't use anymore. Repeaters, sometimes some people use it, but we have advanced router that can cover more networks, and usually we are not using repeater as well, but some in the long distance communications they might be using it. Okay, but very rare. So now next is a router, right? Router connects different networks together. So if your university campus want to connect to the internet, right, there will be a router. So all your internet traffic goes to the router and then your campus can have internet access. Similar with your home, right? In your home you will have a router and modem. So internet traffic first hit to your router and modem, and that's after that it gets to your cell phone devices and laptops or any um, internet devices. Okay. So right now, just get yourself familiar with this terms. Router connects different networks together, direct data traffic between them, and it also assigns the IP addresses to devices in the local area network, right? When you are at home, if you look at your cell phone or laptop devices, each cell phone will get the unique IP addresses, right? Those are the logic IP addresses. We'll deep dive into what is the IP addresses, how it assigned, what are those, what is the IP addressing roles. We'll deep dive into it in later sections. Okay. Delivery of the packet's correct destination to the network. Basically, router use the IP addresses to get to the destination addresses. So router has access to the network layer address and they can work on physical data link and network layers as well. What are the router's features like traffic sequencing, security filtering as well, and some of the network management. Network management in terms of, let's say your email you are sending, this is your home network and you are sending email to your friend, right? um, Router will decide, right? Your friend is sitting in San Francisco and you are sitting in NYC, right? And your friend, your router will decide, right, which way you want to forward your email, right? It takes second to deliver that, but imagine, right, that the routers decide like, hey, this is the best way to send uh, this email traffic to the SFO, and they will take that route. And there will be another route as well. If this route is not reachable, it again go back to this way. but it takes seconds, right? Or sometimes it get delayed, but yeah, usually it's pretty quick even in the entire world. So that's a advantage of the network. And firewall devices, right? It's a security devices. So what firewall devices do? Firewall basically control in and out traffic, right? Firewall is a security device that monitors and controls incoming and outgoing traffic. Even in your home, you can configure in your router has some capacity of the configuring some ports, right? You want to block some website, you can block it, right? Like, hey, you don't want to allow access, your guest cannot access to any other website, right? They can only access to the social media, Instagram, follow Facebook, right? And TikTok or YouTube, right? So you can configure that. So in the guest network, they can only access the social media network. And that's how the firewall plays the role. Gateway. Gateway serves interference between different networks, like translating data between different network protocols or like a data formats and operate in all seven layers of the OSI. Yes, OSI was OSI. We'll discuss in the next session. Okay, don't worry right now. It's a to connect different dissimilar networks and design criteria as well. Uh, TCP/IP to Apple Talk, where we use a gateway. Just get yourself familiar with this term. It generally software installed in the router as well, uh, and it must adjust the data rate, size, and format. This is all we'll learn again deep into during the routing protocols when we learn it. So network interface card, NIC card, is a hardware component that allows computer to connect to a network. Even in your laptop has a NIC card, network interface card. That's where you can plug in Ethernet cable. That's called a NIC card, right? And your now you have wireless NIC card as well, so that will allow you to connect to the wireless network. It is typically integrated into the computers, right? Added to a separate expansion card as well. And what is a proxy server? Proxy server is, let's say there is an organization and one of the user, this is a computer, right? And want to access the internet, and you have a proxy server here. And internet. So you're one of the users in the private organization, like a Cisco, they want to access to the internet. What the most of the organization do is they will first route all the traffic to the proxy, and you configure all the rules. Basically, protect your internal IP address and internal data, right? So outside the world, no one knows who is trying to access what data in the internet, because all internet knows is, hey, I need to forward it to the proxy server, and proxy server will forward internally which user requested this website or this data, right? There are multiple user, one or two, and they will go to the proxy, and proxy will filter it. If there is a malicious traffic, proxy will drop that traffic, right? So for the security purpose, use the proxy server. Proxy server act as an intermediary between a user's device and the internet, forwarding requests and response and providing additional security and privacy features, right? So internet, no one knows who is accessing your traffic. All internet site, let's say if there is a website, right? And they only know is, okay, I need to forward this traffic to the proxy server, and proxy server will decide, okay, user 2 was the one who requested it, so it will send it to that user. So proxy server basically provides additional security and privacy. A load balancer, what is a load balancer? A load balancer distributes incoming traffic across the multiple server to ensure efficient utilization, right? We'll deep dive into it, load balancer, once we are done with the routing and switching labs, because then it makes sense to know like what is a load balancer, how to use it, and how to configure it. I will just give you a highly overview right now. Let's say web traffic, right? Your web traffic comes here from internet. This is internet. Internet traffic goes to the your and you have hosted, for an example, like a freshgrade.com, right? And it is host if it's hosted in one server, then there's no point of using the load balancer, right? But now, if the traffic increases, right? If traffic increases too much, then freshgrade.com server cannot handle it, right? Maximum, like, to get the best performance out of the server, you need to make sure that 80% CPU utilization and 80% of memory utilization. That will give you the best performance. Or if you go 85, 90, or 95, 100, then your web traffic will get hung, right? And then you can't access it. Why? Because your CPU and memory hit the 100% of utilization. So in that case, it's good to have a multiple server, right? Let's say you have a three web server, and we have a three students who want to try to access the freshgrade.com, right? And load balancer, what will do is all three students are trying to access at the same time. And so load balancer will say like, okay, first request come, I will forward it to the server one. And the second student try to access, it will forward it to the server number two. And third student will try forward it to the server number three. So what it load balancer does, it distribute the traffic, right? So once server doesn't have to handle all the traffic, right? All three users traffic won't go to the same server. Okay, and there are many other rules we'll configure it. We'll deep dive into it when we are done with the routing and switching. Then it makes sense to uh, what is a load balancer. Okay, so don't worry, we'll cover it later in detail. An access point. What is the access point, right? I'm sorry you have used access point network, but you are not familiar with it, maybe, right? What is the access point? If you are on the stadium, right? Let's say there is a stadium, and in stadium, there are 60 or 70,000 people are sitting, right? Sorry, I'm bad at drawing, but yeah. Let's say you are in stadium, baseball or soccer or whatever your favorite game. You are sitting in the stadiums, right? And you are accessing the Wi-Fi so smoothly. How come? It's because of the access point, APs, right? So there will be many APs throughout the stadiums are configured, right? And those APs are managed by wireless controller. Okay, I'll just write the WC, wireless controller. Wireless controllers manage the APs, right? And they have some capacities each wireless, right? One, for example, one wireless controller can handle only 10 APs, right? Then you will need multiple wireless controllers as well to provide this internet access to the entire stadium audience. This is where most use case, or let's say if you go into mall, right? How you access the internet through the Wi-Fi, they are using the APs. Okay. And you are familiar with the modem. Modem basically you use it at home, and modem and gateway router, right? At your home. So modem is a modulator or demodulator, converts digital data from a computer into analog signals for transmitting over communication lines and vice versa. That's a modem, right? What is a network storage? A network attached storage? So network attached storage, NAS device provides a centralized storage that can be accessed and shared by multiple devices on a network. So that's a network attached storage. Now let's deep dive into the network topology. Now you are familiar with what are the network devices? If I call nodes, node means a computer, right? And there are different network topologies. Let's deep dive into network topology. First is a star topology. What is a star topology? When you talk about star, right, what it comes in your mind? Exactly, right? Star is a basically you see star in the sky, right? That's what it means, star here in the star topology. And oopsie. Okay. Star topology. So in a star topology, all nodes are connected to the central hub or switch. Now we are not using hub. Okay. Mostly we use the switch. We can call the switch is the best, like better devices, right? And this is a switch or any device that controls all the computers, right? We have one, two, three, four, five, six, seven, and eight. This all eight computers are connected to the switch and they can communicate with each other via. If computer one wants to talk to computer two, it goes through via switch, right? And if want to talk to three, it goes via switch. And what is the advantage? It's easy to install, right? You have one switch and all computers you just plug into the each port. Switch has a multiple ports. We'll discuss into switch section like switch, what are the different types of the switch, how many ports it has, what are the use of the switch, everything, how to configure it, we'll discuss into switch lab, okay? So here if one node fails, it's okay, right? Because switch is still functioning, all other seven, like computer number 2 to 8, they can talk to each other via switch. But this all computer has a one dependency, that's a switch, right? If the switch fails, then they cannot communicate with each other, right? So it's a major dependency. This is the star topology we call. And now next is a bus topology, right? So when you think about bus, yeah, exactly. It is a bus topology, like you are, this is the bus, right? And bus, you will have a suite, seats, right? Both side. Let's say it's a two by two, and there are rows, right? Sorry, I'm bad at drawing, but yeah. So if you get on the bus, right, you use this common this shared space to sit anywhere in the bus, right? If you are sitting in a row three, you still use the same shared space to sit on the bus, right? So similar in the bus topology. In the bus topology, all nodes share a common communication line. Which line? This is the common communication line. And this is the main bus line, okay? So data are transmitted to all nodes, but only the internet recipient receive and process the data. So if this is the computer one, right? 2, 3, 4, 5, 6, 7, 8. If computer one wants to send traffic to 7, it throws simply data into this bus, but it broadcasts to all, right? Even 2, 3, 4, 5, 6, and 8, everyone can access it. But who will take it? Computer number 7, because it's meant for computer number 7. But yeah, again, we are performance degrade. Why? Because we are sending unnecessary traffic to 2, 3, 4, 5, 6, and 8, right? So, but if this main, the bus line fails, then all this computer cannot communicate with each other and the entire network disturb. So this is the bus topology. Now you see the ring topology. So in the ring topology, each node, this is a node or a computer, right, is connected to exactly two other nodes, one in the left and one in the right. You can see one in the right here and one in the left. And the same, this one is connected to this and this and also connected to that, right? So advantage is equal access to the network. So all nodes has equal access to the network. No collision in the data transmitter, data transmit in this circular way in the loop. But if one link fails, right, and then entire network get disrupted because they cannot send the data to another. Or similar way, like if you want to replace this because cable has gone bad, right? Or you want to replace this cable and you will disturb the entire network. Now let's talk about the mesh network. What is the mesh network? So mesh network has the best performance. Best performance, right? Why? Because node 1, if you look at it, is connected to 1, 2, 3, 4, 5, and 6. It's connected to this, it's connected to that, 3, it's connected to number 4, it's connected to number 5, it's connected to number 6. So node 1 wants to communicate to any of the other nodes or computer, right? It can directly communicate with it. So that's why it gets the best performance. And even if this link fails, still node 1 can communicate with the node 2. How? Because it will forward traffic to node 3 and then from there to node 2. Or it can forward from node 4 and send it to node 2, right? Even if the two links fail, still network works fine. Okay. But it's more costly. Why? Because you see, you have to run so many cables, right? And it's complex and to install as well, and it's very tough to manage as well, the mesh network. Main advantage is high redundancy, right? Fault tolerance. If one or two links fail, it's still they can communicate with each other. So now let's talk about another hybrid network topology. So hybrid network topology is a combination of two or more different topology. We talk about the bus topology, right? This is the bus and this is the star. So now you are using the two different topologies, and that's called hybrid topology. Okay, you can use any like a tree or any other topologies to basically create the hybrid, or you can use a ring as well. What is the advantage? Provide the benefits of the multiple topology. You can simply you have benefits of the bus and star topology. Okay, and it can be a little bit complex to design and implement when you are implementing two different topologies. Now let's look into tree topology. What is a tree topology? Basically, tree topology combines the characteristics of the star and bus also. Hybrid, right? So tree topology basically combines star and bus. How you see? Can you see it? Um, so this is the star. You see, because in the similar way here, right? Star. You have one switch and that is connected to all other computers, right? So one switch is connected to here three devices. And that three device again connected to this is the main backbone bus. It's connected to the bus, right? And right here, this is a star, and star is connected to the bus. This is the bus, right? It is scalable and can cover larger areas as well, and dependency on the central backbone. If this central backbone fails, then it can affect the star network as well because these guys can communicate to each other, but if they want to communicate to this guy, then they have to go through this backbone bus, and if backbone bus fail, they cannot communicate, and that is the main dependency. Now let's take a look here, right? How you can decide like what is the best criteria? It depends on your requirement, right? Which network topology you want to use, star, bus, ring, tree, or mesh, right? It depends. You can go for a mesh if you need a like highest reliability and great efficiency, and you don't worry about the cost, right? Cost, yeah, a lot of money. Company has a lot of money, they can go with the mesh. But otherwise, this tree is also best, like logically. Reliability is also better, like efficiency, right? And this is a another best network topology to leverage it. And ring topology, cost is high again, but bad reliability, but better than the bus efficiency. So if you see here, bus is the worst topology to have it only. Right? In the star topology, cost is very less, but it's very good. Star topology is being used in many corporate network as well. Okay, but they what they do is they configure two star network, one and two, by leveraging two different switches, and they can configure in the stack, and that's where they have redundancy. Okay, and here I just lay down some of the differences: bus, starring, mesh, tree, and hybrid, whatever we discuss, right? Bus device connected to the single central cable or backbone, easy to install, minimal cabling, but it's difficult in troubleshooting and limited performance, right? Early LAN setup, small networks, you can use a bus, but not recommended. Star, Device connected to central hub or switch, right? Let's talk about switch. It's only connected to the central switch. Centralized management, easy to troubleshoot, and single point of failure, right? If that switch fails, then entire star network goes down. It can be used in home, enterprise lane, or setups. So many in enterprise star network is being used. Ring, I never seen the ring being used in any enterprise or network. Okay. Devices form a closed loop with each device is connected to two others. Data flows predictably in one direction, right? Like this. And break in the ring can disturb the entire network. And mesh network, mesh is the best network in the world, right? Devices are interconnected, creating a multiple paths for data travel, high redundancy, reliable, and fault tolerance as well as. But it comes with a higher cost and complexity. It's very complex to manage. It's being used for the WAN, wide area network in internet, data center, missions, or critical applications. So yes, in the data center, what network we are using? Mesh mostly, and star in the some of the corporate office network. But we don't use a bus. So if you need to remember, mesh is the best. We'll deep dive into it. Don't worry right now. When we are done with the routing protocol switching, right? When we discuss the network architecture, during that time, how you configure the entire data center network or corporate network, during that time, I'll discuss the mesh and star topology. So star topology we use in the corporate offices and mesh mostly in the data center. Combination of the bus and star topology with the hierarchy levels is scalable, centralized control as well. But again, if the backbone fails, the entire network goes down. Some organizations they may leverage the RE as well. Hybrids combine two or more topologies to meet the specific needs. What is the pros? Flexible and scalable and complex design to manage. And in the data center, they can use the hybrid topologies as well. So now address mechanism. So what is a MAC address that comes in your mind, right? Everybody, you might know the MAC. MAC and physical address is the same word. Okay. So MAC is equal to physical device, physical address. Okay. And MAC address has a 48 bit. What is a 48 bit? So in 48 bits, there are 6 octet, and each octet has a 8 bit. 1, 2, 3, 4, 5, 6, 7, 8. And this is in the binary, ones and zeros. And computer only understand 1 and 0 in language. Okay. Why we are using the decimal and hexadecimal? It's for human understandable. Okay. But all computer understand is 1 and zeros. So MAC address is a unique identifier assigned to a network interface cards on a device. And think of it's a device fingerprint for a network, right? This is the fingerprint for a network. When right before some of the phones support the network, like a fingerprint to unlock the device, right? In the similar way, MAC addresses is a fingerprint of for a network for each devices. And each device has a unique MAC address. Okay, you cannot have this two same MAC addresses for uh, two different devices. No, then that will create issues. Okay. Sometimes to do in the virtualization you can overwrite it and that can create issues, but we'll deep dive into the switching section and switching labs. Okay. So don't worry right now in too much. So in this first 3 octets, right? Octet 1, 2, and 3 is organizationally unique identifier is basically for organization like if IBM or Google or Nvidia, right, which organization is using it. And this is for network interface, controller specific what bandwidth, and it provides the detail of the network interface controller card. And in this one, if you use into first octet, you will see like B0, B1, B2, B3, there are 8 bits. So total 48 bits, right? In one octet, you have 8 bits. So 8 8 here, 8 here, 8 here, 8 here, 8 here, 8, right? So 8 into multiply by 6. So that's become your 48 bits, right? And B0 is a unique unicast and B1 is a multicast address. And in the B0 here, you will see 0 and 1 unicast and 1 for multicast. And in the B1, you will see 0 means globally unique OUI enforced and 1 is means locally administered. So if you see the MAC address and the first octet, you can see it right here, binary. But mostly what we see is here hexadecimal. So that's why we don't know. And unique identifier, right? MAC address is a network interface, or like in a Wi-Fi computer, or even your Ethernet port, or in your iPhone device or Android devices, you will have unique MAC addresses when it's made. No two devices on the same network should have the same MAC address, otherwise create an address. What is the format for here? We can say this is the format, right? AA. This is the hexadecimal format. And in the OSI layer, you will see the MAC address as the layer L2. It's called data link layer. We'll deep dive into the next lecture. Okay, so don't worry. And local network communication. MAC address is basically switch where it's stored in the switches. Okay, we'll deep dive into switch section, switching labs, and switching protocols. So at that time, we'll learn how do you see the MAC addresses, what is the MAC addresses, right? And we'll also look at the ARP and we'll show you how that works. So this switch basically we use for local area networks. What is the main role here is when data is sent over the local network, it uses the MAC address to ensure the information reaches to the right devices, right? So now in your local home, right, if there are 10 devices and they want to send it to specific devices, what they use is they use a MAC address. There's a MAC address to send it to the right device data. So MAC addresses are like security purpose are unique, but they can be spoof, as I say, right? Someone can fake your MAC address, wipe it out, and they can rewrite it over as well. But that's not recommendable. Okay, it's not ethical or legal thing to do it. And now let's look at the IP addresses. What is another networking term is IP address. So IP addressings are uniquely identify on a device on IP network. So each mobile network has a different IP addresses. It's 32 bits IP addresses, port addressing. And each port has a 16 bits of port address. We'll deep dive into during the IP address lecture. Okay, IP addressing it. So in IP addressing lectures, we'll learn how to binary to decimal and decimal to hexadecimal as well. It's very important to clear your IPv4 concept. Okay, you must know binary decimal, decimal to hexagonal. So I will show you how to do that. And this is the range of logical address, class A, class B, class C, class D, and class E. So IPv4 total range is 0.0.0 to 255.255.255.255. If someone says like, oh, your IP is 256 dot something, don't believe it. It's wrong. Okay, it's not IPv4 address. This is the IPv4 address range. So if any IP or any devices have IP addresses that's within this range. These are the total IP addresses. Okay. So IP address is a unique numerical like a label assigned to each device connected to the computer network that use the internet protocols, right? And it works like a postal address, ensuring that data sent across the network and reaches to the correct destination. Okay. Logical addressing, unlike the physical address like a MAC addressing, IP address are logical. So this that's why we are calling the logical addressing. MAC addresses are hardened and enforced in each devices, but IP addresses can be changed whenever you switch the networks, right? You are in the Starbucks office, you will have different IP. If you are in the Cisco network, you will have a different IP addresses. If you are in a home or Wi-Fi internet connection, you will have a different IP addresses. So that IP addresses can change. And IP addresses has a 32-bit version, and you will see the 4 octet. Okay, and each octet has a 8-bit. And IPv4 supports 4.3 billion unique addresses due to the explosion of the internet connected device. IPv addresses have become the scare now, right? Because we have billions of devices, cell phones, and small devices. So, and thing is, we have already surpassed the more than 4.3 billion unique addresses. That's why we have to go for IPv6. But in still many cases, many organizations are using the IPv4 address. If small organization doesn't need more IPs, they can still leverage the IPv4 addresses. Okay, we'll discuss during the IPv addressing and routing protocols and switching. Now let's take an example. So IPv4 has a 4 octet, okay, and each octet has a 8 bits. So that's why it's called 32 bits. So we have now 4 bytes, 1, 2, 3, and 4, and each has a 8 bits. You can see, you can count here, right? 1, 2, 3, 4, 5, 6, 7, 8. And this is, you see, one is a simple, right? But we'll learn in how you can convert from 254, this is a decimal number, to this binary. And remember, computer only understand 1 and 0. Computer doesn't understand what is 172. Whenever you type 1, it converts into binary 1 and 0. Okay, so computer doesn't understand what is 172. It's only understand the binary. Now, if you see here, network ID and host ID will discuss into the IP addressing um, classes. But one way easy is you just need to remember this range. Okay, class A has a 0.0.0 to 122.7.255.255.255. So if you see here, once it's reached 255.255 last 3 bytes, right, then it gets incremented into the first byte right here, and that's become 128, and that's where it starts the class B, right? In a similar way, you see here 191.255.255.255, and the next range start basically increment to here 2. So it's like 192.0.0.0 and 223.255.255.255, and again it's all maxed out. Remember I told you the maximum each byte can have value is 255. Why? Because if you convert that into binary, your first byte becomes this is the value, right? So it maxed out at the 255, and that's why this is the range from 0.0.0 to 255. And then what happened is it gets incremented into the first byte, right? So it becomes 224.0.0 to 239.255.255, and then again it increases 1, 240.0.0 to 255.255.255.255. This is the total range. So if you see here, what is our range here? It starts from 0.0.0 to right here, 255.255.255. But we have divided in different class. There are 5 class, but the class 5, class E, is reserved. So we don't use class E in most of the use cases, okay? And what are the private IP addressing? So why we have given the private IP address and public IP addresses? Private IP addresses we use for the most organization. Like if the Cisco company use private IP addresses within their network, and that can be common. It's okay, right? That can be overlap from one network to another network. But again, when they're let's say Cisco campus is communicate with the Apple campus, right? They use the public IP addresses, but there is a high possibility, or there is a possibility they are using it, right? So in the Apple internet internal network, they can use this private IP address as ABC. Same Cisco internal, they can use this one, and you don't know, but externally in internet don't know. In internet we use the public IP address. Okay, so if someone says the private IP address is assigned, right? That's mean that user or that laptop or any cell phone or any like network devices is being connected to the private network. Private network can be Cisco network or Apple or Google or any Nvidia or any other networks. Okay. So in the class A, there's a private IP address is 10.0.0.0 to 10.255.255.255. Okay, and it's a 24 bits. You see here, right? It's a 24 bits is a host ID. So only 10 doesn't change here, right? And there's a range. So this is how many bits? 24, right? 8, 8, 8. That's called 24 bits. So in the 24 bits, you can have so many hosts you can, connect. And there's a network ID. So now in the class B, 172.16.0.0 to 172.31.255.255. So in the class C, what is the network ID and host ID? Let me show you here. So this is the network ID. Why? Because this is the fix and this is the range that many computers can be or host can be connected to within this range. Okay. So if you see here, it's a 20 bits, and here we see is a 12, right? So total 32 bits. Okay. Here is a 12. So and this is the network ID and this is the host ID. We'll deep dive into the IP addressing. So don't worry right now. Don't think like you don't know. This is just a first like a high level. But again, we're gonna deep dive into it. We first need to learn binary to decimal, decimal to hexadecimal, right? We need to practice on this and then we'll deep dive into how the IP addressing works. And the class C 192.168.0.0 to 192.168.255.255. So in the class C, you see the network ID is a fixed. Okay, this is the network ID. And 0.02, 255.255.255. These are the host ID. All right. And there are some limitations in the logical addressing. Um, so flexibility within the existing address schemes, right? Sometimes you run out of your subnets. We'll discuss into network with the multiple departments, right? How we want to logically separate them. One department has a 300 devices, another has a 300 devices. How we want to logically separate that will discuss into subnetting, LAN, and VLAN concepts. Okay, so when we do IPv address, right, we'll learn how to do subnetting, supernetting, public and private host, what are the network ID and host ID, how you can determine it. We'll deep dive into IP addressing session. Again, what is subnetting high level? Process of borrowing bit from host ID to generate subnet ID. Don't worry, we'll deep dive into the IP addressing class, okay? But when you want borrow one bit to generate the sub ID, that's called the subnetting. Subnet mask indicates how many bits are borrowed, like how many subnets are available. Always refer to the single network, right? And there is a super netting concept as well. We'll discuss deep dive into it. Process of aggregating, like main network in generating signal network. This is a supernet mask, like how many networks are associated with the generate a single IP network. always refer to multiple networks as well. All right, thank you so much for today's class. And the next section we'll learn OSI model.